Mathematics. It is notorious for being a difficult subject for many people. When you think of math, you often think of numbers or endless algebra or calculus problems. Indeed, problem solving is an intrinsic characteristic of mathematics education. But math is more than that, and oftentimes, in many ways you may not think of. If you give a rectangle a half twist with their ends joined, you'll form a unique figure called the Mobius strip. This object has very interesting properties. When you cut it in the middle line, it stays in one loop. Try it. Now, how is this math? Well, we have a branch of mathematics called topology. As you can see, this is a geometric field of study, but a special one. In a sense, you are studying geometric spaces that are preserved by continuous deformations. Now, when you actually study topology, you will encounter rigorous mathematical proofs and often really advanced lessons. So in this video, we will spare you the details. But here's another demonstration of topology. For a topologist, this coffee mug and this donut are actually equivalent. Why? Thanks to the fact that they only have one hole, you can deform this one into another, and you can consider these two objects topologically equivalent. Let's talk about numbers. Let's count with a twist, starting with 1, then a number which is the sum of the two preceding ones. So 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. What you form is a Fibonacci sequence. Now let's do a Fibonacci tiling. Let's add a square, whose side length is the term in the Fibonacci sequence, next to the previous square in a counterclockwise manner. Then let's draw a circular arc and connect the opposite corners of squares in the Fibonacci tiling. You form a golden spiral. It is described by the golden ratio. You observe this in many beautiful photographs like this. Mathematics also encompasses a crucial aspect, logic and reasoning. A lot of higher level mathematics is actually built on mathematical proofs. We start with the basics. You have a mathematical statement. For instance, that sentence is a mathematical statement. That statement can be true or false. You can negate it. You can add another statement where if one statement is false, the entire sentence is false. You can also make it so that if one statement is false, the entire sentence is still true. You can also make a statement a condition for another statement. Or you can make it biconditional. But oftentimes, you will have to prove that a mathematical statement holds. Now, there are multiple ways you can prove mathematical statements, but I will show you a few basic examples. Prove that for every integer x, the integer x times x plus 1 is even. Here's the answer. This is an example of a direct proof. Now prove that it is false that every rational number is an integer. We can provide a counterexample as a proof. Here is the proof. From this, we can formulate proofs on advanced topics, and it's the mathematician's goal to prove or disprove those proofs. Remember that you can graph an equation in a coordinate plane. The graph represents the set of points in the coordinate plane that are solutions to the equation. With this knowledge, we can formulate interesting graphs through these equations. We can use the polar coordinate plane, which uses the radius and the angle from the origin as the polar coordinate, to generate interesting graphs. Furthermore, we can use the 3D coordinate plane to graph 3D figures. Still sticking to geometrical figures, we have patterns that seem to never end. This is called a fractal. They have very detailed structures at small scales. Here are some other beautiful photographs featuring fractal geometry. Math is indeed a vast field of study where you can approach it from different perspectives. We often view math from a problem-solving perspective. While math is indeed taught through problem-based learning and it helps us develop our skills, math can be made more enjoyable when you also approach it from a different perspective, where you appreciate its beauty and complexity. I do hope you appreciate math more after watching this video. Thanks for watching.